China's supercars are 100 years ahead of Ferrari, Lamborghini, and Bugatti. And we're not talking about slightly faster acceleration or better tech screens. We're talking about cars that jump over obstacles on command, cars that learn your driving style and rewrite their own software, cars powered by hydrogen that refuel in 3 minutes, and machines that just destroyed the Nürburgring lap record while costing a fraction of what European hypercars demand. While the West argues over whether to add hybrid systems, China's building vehicles that make a Bugatti Chiron look like a museum piece. We're counting down 14 cars that will make you question everything you thought you knew about automotive engineering. And what you're about to see at number 1 will absolutely terrify Stuttgart, Sant'Agata, and Molsheim. Qiantu K50. You're looking at the Qiantu K50, and the engineering here is surgical. Aluminum space frame wrapped in carbon fiber, total weight under 3,000 pounds. Twin electric motors mounted at the rear axle. Over 400 horsepower driving the back wheels with zero interference. The power delivery is instantaneous, no turbo lag, no transmission hunting, just pure linear acceleration that pins you to the seat. But here's what separates this from every other electric sports car: the suspension geometry. Double wishbones at all 4 corners, with adjustable damping that responds in milliseconds. The chassis is so stiff, so precisely tuned, that every input translates directly to the road. 0 to 60 in 4.6 seconds isn't the story. The story is how connected you feel when the car rotates through a corner, how the weight transfers exactly where you need it. This is emotion through engineering. But the real shock comes when you see what China did next. Neta GT. The Neta GT is where China stopped apologizing for making electric cars affordable. 3 electric motors sewn up front, 2 at the rear producing 560 horsepower combined. The engineering trick here is the torque vectoring system. Those 2 rear motors don't just spin the wheels, they actively control how much power each wheel gets in real time, adjusting thousands of times per second. You turn into a corner, and the outside rear motor pushes harder, while the inside one holds back, rotating the car with surgical precision. 0 to 60 in 3.7 seconds, but the acceleration curve is what matters. Linear power delivery from 0 RPM all the way to top speed. No drop-off, no waiting for power band. The battery pack sits low in the chassis, dropping the center of gravity below the axle line. What that means in practice is a car that corners flat, rotates on command, and feels like it weighs half of its 4,000-pound curb weight, and they're selling this for under $40,000. But wait until you see what happens when China takes British heritage and rebuilds it from scratch. MG Cyberster. The MG Cyberster is a masterclass in aerodynamic efficiency disguised as a roadster. Retractable hardtop that deploys in under 10 seconds. But here's the engineering brilliance. The roof panels are carbon fiber composite, adding zero weight to the top-heavy problem every convertible faces. The body is shaped in a wind tunnel for months until they achieved a drag coefficient of 0.28. That's Porsche 918 territory. Dual motors producing 536 horsepower. But the real innovation is the battery architecture. Cells arranged in a skateboard platform so low that the entire passenger compartment sits below the beltline, giving you a center of gravity that defies physics. The result is a car that hits 60 miles per hour in 3 seconds flat, while maintaining perfect 50-50 weight distribution front to rear. Active suspension reads the road surface 1,000 times per second, adjusting damping rates before your brain even registers the imperfection. Scissor doors aren't just for show. They're shaped to channel airflow over the rear diffuser at speed, creating downforce without adding drag. But China wasn't done experimenting with alternative powertrains. RG Nathalie. The RG Nathalie runs on methanol fuel cells, and the engineering here is genuinely revolutionary. Forget everything you know about electric range anxiety or hydrogen infrastructure problems. Methanol is a liquid you pump like gasoline, except it's feeding a fuel cell stack that generates electricity on demand with zero emissions. The chemical process is elegant. Methanol combines with oxygen, produces electricity, and outputs water vapor and trace CO2. 4 electric motors, 1 at each wheel, delivering 400 horsepower with independent torque control that makes traditional all-wheel drive systems look primitive. But here's the breakthrough. You get 350 miles of range, and refueling takes 3 minutes. 3 minutes, the same time it takes to fill a conventional sports car. The methanol tank is carbon fiber, positioned centrally for perfect weight distribution, and the fuel cell stack is compact enough to fit where a traditional engine would sit. The power delivery is instant, smooth, and relentless. 0 to 60 in 2.5 seconds, with a top speed of 186 miles per hour. The chassis is aluminum and carbon fiber composite, total weight just over 3,000 pounds. This is the bridge technology everyone said was impossible electric performance with liquid fuel convenience. But the next car took artificial intelligence and turned it into a track weapon. Arcfox GT. The Arcfox GT has Huawei's full artificial intelligence system controlling every aspect of the drivetrain, and the results are terrifying. 4 electric motors producing 1,160 horsepower, but raw power is just the starting point. The AI analyzes 70 different vehicle parameters, 10,000 times per second: tire slip angle, suspension, compression, steering input, brake pressure, weight transfer. It's predicting what you're about to do before you even complete the motion. You turn the wheel and the system has already shifted torque to the outside rear motor, stiffened the dampers on the loaded side, and adjusted brake bias. The reaction time is 0.003 seconds. Humans can't even perceive changes that fast. The aerodynamics are active front splitter adjusts angle based on speed and cornering force. Rear wing deploys in stages depending on downforce requirements. At full deployment, you're generating over 1,000 pounds of downforce at 150 miles per hour. The chassis is a carbon fiber monocoque, the same construction Formula One teams use. Total weight 3,200 pounds, 0 to 60 in 2.5 seconds, quarter mile in 9.8. But here's the engineering miracle. The AI learns. Every corner, every lap. It's optimizing the torque split and suspension settings for your specific driving style. The car literally gets faster the more you drive it. And what came next made this look conservative. HiPhi Z Performance Edition. The HiPhi Z Performance Edition has gull-wing doors that are 12 feet wide when fully opened. And they're not just for drama. Each door houses active aerodynamic elements that deploy independently based on vehicle speed and lateral G-forces. The door panels themselves are aluminum honeycomb covered in carbon fiber, weighing just 60 pounds each, despite their massive size. Biometric sensors embedded in the door handles read your fingerprint and heart rate simultaneously, unlocking in 0.4 seconds. But the real engineering is inside. The digital cockpit uses 19.9 inches of curved OLED display with a refresh rate of 120 Hz faster than most gaming monitors. 3 separate computing processors running simultaneously, managing everything from the adaptive air suspension to the predictive climate control that adjusts temperature based on your skin conductivity. Dual motors producing 672 horsepower. Torque vectoring system that can shift power from front to rear in 0.01 seconds. The battery pack is an 800-volt architecture, meaning you can charge from 10 to 80% in 15 minutes with the right infrastructure. Active suspension has LiDAR sensors scanning the road 30 meters ahead, pre-adjusting dampers before you hit imperfections. 0 to 60 in 3.2 seconds. But the handling balance is what stuns you. 52%, front 48% rear weight distribution, despite the massive battery pack. Then China took a family sedan platform and turned it into something absolutely unhinged. Zeekr 001 FR. The Zeekr 001 FR puts quad motors into a sedan body, and the numbers are absurd. 1,268 horsepower, 6,332 pound-feet of torque at the wheels. Each motor is individually controlled, meaning you have 4 independent power sources that can vector torque in ways that rewrite physics. 0 to 60 in 2.07 seconds. That's faster than a Bugatti Chiron. Faster than a Rimac Nevera. In a car with 5 seats and a trunk. The engineering to make this work is staggering. Silicon carbide inverters that can switch current on and off 50,000 times per second, reducing heat and increasing efficiency by 18%. The battery pack is a blade cell designed thin, flat lithium iron phosphate cells stacked like a deck of cards, creating a structural element that stiffens the chassis while storing energy. 800-volt architecture means charging speeds that add 100 miles of range in 5 minutes. But here's the innovation that matters. The torque vectoring isn't just side to side, it's diagonal. The system can send power to opposite corners simultaneously, creating rotation angles that traditional all-wheel drive systems physically cannot achieve. Active rear steering turns the rear wheels up to 5 degrees in the opposite direction at low speeds, making a 16-foot-long sedan handle like a go-kart. Carbon ceramic brakes, 16.5 inches front, 15.7 rear, with 10-piston calipers. You need that stopping power when you're carrying this much speed. But China was just getting started with radical aerodynamic thinking. GAC ENO.146. The GAC ENO.146 has active body panels that physically reshape the car while you're driving. Not adjustable wings or flaps, the actual body panels morph. Shape memory alloy actuators embedded in the carbon fiber skin can change the surface contour by up to 3 inches in specific zones. At low speeds, the panels create a smooth, low-drag profile for efficiency. Push past 100 miles per hour and sections of the rear quarter panel flex outward, creating defined air channels that feed the rear diffuser. The front fascia has 14 independent active elements that open and close air intakes based on cooling requirements and aerodynamic load. When you brake hard, panels deploy instantly to create air resistance, adding 200 pounds of stopping force through pure aerodynamics. The result is a drag coefficient that ranges from 0.21 in efficiency mode to 0.38 in maximum downforce configuration. Dual motors producing 816 horsepower, but the power delivery is tuned around the aerodynamic changes. Acceleration curves are programmed to match the body transformation. Sequences the panels morph. Power output increases proportionally, so you never feel the added drag, just relentless forward thrust. The chassis is a carbon fiber and aluminum hybrid structure. Total weight 3,400 pounds. Active suspension with 48 individual air springs that can adjust ride height in 2 mm increments, dropping the car 60 mm at speed to reduce frontal area. 0 to 60 in 2.8 seconds with a top speed of 193 miles per hour. But the next car came from a company that had no business building supercars at all. Xiaomi SU7 Ultra. The Xiaomi SU7 Ultra is what happens when a technology company designs a car from pure data. 13,000 sensors throughout the chassis, body, and drivetrain, feeding information to 3 separate neural processing units that make 40 million calculations per second. The AI doesn't just assist, your driving it fundamentally changes how the car behaves based on patterns it detects. 3 motors producing 1,527 horsepower, but the torque distribution is never the same twice. The system analyzes tire temperature, road surface grip, ambient conditions, even your steering input pressure, then optimizes power delivery for that exact millisecond. The battery is a Qilin cell designed 960 watt-hours per liter energy density, the highest in any production vehicle. That translates to 400 miles of range despite the massive power output. The cooling system is liquid-based, with micro-channel heat exchangers that maintain cell temperature within 2 degrees Celsius regardless of load. 0 to 60 in 1.97 seconds. Quarter mile in 9.2 seconds at 153 miles per hour. The aerodynamics are computational fluid dynamics, taken to the extreme every surface angle, every vent placement. Optimized through 10 million virtual simulations. Active rear wing has 9 separate deployment positions, adjusting every 0.3 seconds based on speed, brake force, and cornering load. The chassis is a carbon fiber tub weighing just 180 pounds, wrapped in aluminum subframes front and rear. But here's the part that changes everything. Over-the-air updates that rewrite the torque maps and suspension algorithms. The car literally gets faster after you buy it. But Xiaomi's tech wizardry was about to look conventional compared to what happened when China decided to shatter 8 Guinness World Records with a single car, Hyptec SSR. The Hyptec SSR holds 8 Guinness World Records, and every single one of them is a middle finger to traditional automotive engineering. Fastest acceleration for a hydrogen vehicle, 0 to 60 in 1.8 seconds. Fastest quarter mile for a fuel cell car, 9.1 seconds. Highest top speed for a hydrogen-powered vehicle, 248 miles per hour. Lightest hydrogen supercar at 2,800 pounds. The records keep going. 4 electric motors, 1 at each wheel, producing 1,200 horsepower with independent torque vectoring. carbon fiber monocoque chassis with titanium suspension components weighing half what steel equivalents would. The power-to-weight ratio is 9.6 pounds per horsepower. That's better than a Formula One car. Ceramic matrix composite brake rotors that can handle 2,500 degrees Fahrenheit without fade. The aerodynamics use ground effect principles with a shaped underbody, creating a Venturi tunnel. At 150 miles per hour, you're generating 850 pounds of downforce while maintaining a drag coefficient of 0.24. Active suspension reads the road surface and adjusts damping in 0.002 seconds. The hydrogen fuel cells deliver 370 miles of range and refuel in 3 minutes. 8 world records. 1 car. And it's not even close to the most extreme thing China built, Hongqi S9. The Hongqi S9 produces 1,514 horsepower from a 4-liter twin-turbo V8 paired with 4 electric motors. 896 horsepower from combustion, 618 from electric. All feeding through independent torque vectoring to each wheel. 0 to 60 in 1.9 seconds. Top speed of 251 miles per hour. The carbon fiber monocoque weighs 412 pounds. Butterfly doors channel air directly to the rear brakes at speed. Active Aero generates 1,800 pounds of downforce at 180 miles per hour through a 7-position rear wing and extending front splitter. Pushrod suspension with horizontal dampers, the same setup Le Mans prototypes use. Carbon ceramic brakes, 16.9 inches front with 10-piston calipers, 51% rear weight bias. This is a hybrid V8 supercar that makes a Ferrari SF90 look underpowered. But then came the car that destroyed the most famous racetrack on Earth, Nio EP9. The Nio EP9 lapped the Nürburgring in 6 minutes 45.9 seconds. That's faster than a Lamborghini Aventador SVJ, faster than a Porsche 918 Spider, faster than almost every hypercar ever built. 4 electric motors, 1 at each wheel, producing 1 megawatt of power. That's 1,341 horsepower. Each motor weighs just 88 pounds, but delivers over 300 horsepower independently. The torque vectoring system adjusts power distribution 800 times per lap around the Nordschleife, optimizing for every single corner. The battery is a lithium-ion pack, positioned as low as physically possible, dropping the center of gravity to just 14 inches off the ground. Active aerodynamics generate 5,300 pounds of downforce at 180 miles per hour more than the car weighs. The front splitter and rear wing work together, creating a ground effect so powerful the car could theoretically drive upside down at 160 miles per hour. Carbon fiber monocoque chassis weighs 365 pounds. Total vehicle weight 3,700 pounds with a power-to-weight ratio of 2.7 pounds per horsepower. 0 to 124 miles per hour in 7.1 seconds. Top speed 194 miles per hour. Limited only by aerodynamic drag from the massive downforce. The braking system is regenerative and friction combined. The motor's reverse polarity to slow the car, while carbon ceramic rotors provide backup stopping power. Nio set that Nürburgring time in 2017, 7 years ago, and they've barely talked about it since. But the next car took physics and said the rules don't apply anymore. BYD Yangwang U9. The BYD Yangwang U9 can jump, physically jump off the ground on command. 4 independent motors producing 1,100 horsepower, but that's not the story. The story is the hydraulic suspension system called D-Sus X that can extend or compress each wheel independently by up to 5.9 inches in 0.5 seconds. You press a button and the car bounces 3 feet into the air. The system generates enough force to lift the entire vehicle off the ground and hop over obstacles. But it's not a party trick, it's advanced engineering borrowed from BYD's Defense Technology division. Each corner has its own hydraulic actuator, controlled by sensors that monitor wheel position, body roll, and G-forces 1,000 times per second. Hit a pothole and the suspension extends that specific wheel before impact, cushioning the blow. Hard cornering and the outside suspension compresses while the inside extends, keeping the body completely flat through turns. The car can drive on 3 wheels if one fails, redistributing weight and torque automatically. 0 to 60 in 2.36 seconds with launch control that uses the suspension to squat the rear and lift the front, maximizing traction off the line. The motors deliver torque vectoring with individual control. Each wheel gets exactly the power it needs for optimal grip. Carbon fiber body panels over an aluminum space frame. Total weight 4,800 pounds, despite the complex hydraulic system. Top speed electronically limited to 192 miles per hour because the aerodynamics weren't designed for stability, they were designed for adaptability. But what came next is the car that combines everything China learned into one absolutely devastating package. Xiaomi YU7. The Xiaomi YU7 is everything China learned, from building 14 previous supercars, compressed into one machine that makes traditional hypercars look like antiques. Tri-motor setup producing 1,500 horsepower with silicon carbide inverters switching 50,000 times per second for zero power loss. Qilin battery cells with 960 watt-hours per liter energy density, delivering 450 miles of range, despite the insane output. 0 to 60 in 1.78 seconds. Quarter mile in 8.9 seconds at 162 miles per hour. The aerodynamics use active morphing panels combined with ground effect. The entire underbody is a shaped Venturi tunnel, while the body panels physically reshape at speed. Drag coefficient ranges from 0.19 in efficiency mode to 0.42 in maximum downforce configuration, generating 2,100 pounds of downforce at 170 miles per hour. Carbon fiber monocoque weighs 192 pounds, total vehicle weight 2,900 pounds. Power to weight ratio of 1.93 pounds per horsepower. The AI system processes data from 18,000 sensors, making 60 million calculations per second, controlling torque vectoring, suspension, aerodynamics, and brake bias simultaneously. The suspension uses electromagnetic actuators that respond in 0.001 seconds, reading the road surface 40 meters ahead with LiDAR. Over-the-air updates continuously. Optimize performance. The car learns your driving style and rewrites its own programming. Top speed of 268 miles per hour, making it faster than a Koenigsegg Jesko. And Xiaomi is selling it for $90,000. $90,000. That's the price of a loaded Mercedes. This is why Ferrari, Lamborghini, and Bugatti should be terrified. The future just arrived, and it costs less than a used Huracan.